Alright, this video is on operations of radicals, so namely how do you add, subtract, multiply, or rationalize radicals. So we've already done simplifying radicals, so that will be built into this, that will be built into this particular video that you already know how to simplify radicals. If not, then please go back and check that other video out first. We're just going to address each of the three different things on their own and do some examples within. So first is adding or subtracting with radicals. In order to add or subtract with radicals, you should do the following two things. One, simplify all the radicals first if they can be simplified. And then two, combine like radicals. So like radicals are radicals that have the same radicand, the same numbers underneath the radical. Once they are like, we keep what makes them like, and then we combine the coefficients. So basically what I'm saying here is that this expression, this example, the example is kind of the easiest way to teach this, is not dissimilar to me saying this. Right? X is just a variable that stands for some number. So in this case, the number would be square root of 7. And this is supposed to be a 3, not a 5. So if I want to do this, if I wanted to do the x's, I would do 9 plus 3 is 12. 12 minus 4 is 8, so the answer would be 8x. With radical, it's no different, just now I know that the x is the square root of 7. So this is saying how many square root of 7s are there? So there's 12 minus 4, or 8. There's the adding and subtracting the coefficients. Keep the radical, square root of 7. It's easy as long as we let it be easy. Do not combine the numbers underneath the radical. That's saying that the values is increasing drastically, and that's not what's happening. So simplify, keep the number under the radical the same, combine the coefficients. So obviously we need to do an example where it's a little bit more complicated. It's that second case where I actually have to simplify. So here, if I look at these initially, no like radicals. So I need to do that step one. I need to simplify my radicals. I'm going to go factor tree method for all these just because it's where my brain is at the moment. So that's what I'm going to do. When I factor tree this, I get 3, 3, 3. I'm just going to go through and do all my factor trees first. 2, 2. And this is, I see 4 and 12 when I first look at it, so I'm just going to go with that. Again, maybe your factor trees initially are starting different, but at the end they should all be the same. All right, so I'm ready to simplify. These are all square roots, right? So I'm going to kind of take my highlighter, and maybe you're working with a highlighter while you're doing this. If so, that's great. If not, and you're getting stuck, maybe I encourage that you go out and you pick up your highlighter and you start doing that. It might help you pretty drastically. So I'm just going to kind of underline the numbers that are left so I don't lose them along the way. All right, I'm ready to go now. So this first guy simplifies into 3, because this comes out as a group of 3's, times the square root of 3, minus. The middle radical had a 3 in front of it already, so I'm going to carry that down. This group of 2's gets pulled out. This 3 gets left inside, plus the 5 was there, parentheses, what do we get when we simplify? What comes out is 2 times 2, what gets left inside is the 3. So I'm going to get rid of all my parentheses now. So I have 3 square root of 3 minus 6 square root of 3 plus 5 times 2 is 10, 10 times 2 is 20 square root of 3. Now we have like radicals. These are all root 3's. So my answer is going to have a root 3 in it. And we said we take all those coefficients and put them together. So I'm doing what's 3 minus 6 plus 20. Your calculator can do that for you if you don't want to. 3 minus 6 is negative 3. Negative 3 plus 20 is positive 17. So my final answer here is 17 times the square root of 3. So simplify, don't forget those coefficients. Very easy mistake to make, but they make a big difference on your answer. And then from there, multiply anything out in front, clear your parentheses, combine the coefficients, keep the radical. Not so bad. Next thing we need to talk about is how do we multiply radicals. So with radicals, you multiply numbers by numbers, so coefficients by coefficients, then multiply the numbers underneath the radicals by each other, and then simplify the radical. Multiply the coefficient by the simplified radical at the end. Now, I'm going to do something a little bit funny in this, and you'll understand why once you kind of follow along. So in this first example, it says multiply the coefficients. So 5 times 3 here gives me 15. Then it says multiply the numbers under the radical. I'm actually not going to multiply them together, because when I simplify, I often do factor tree, and this is like, actually let me go back here. This is like starting the factor tree with 6 and 2. I don't care what the number is, but I'm going to start to break it down in a second anyways. So I'm going to go ahead and leave it as 6 times 2. Then I have my factor tree all set. I'm going to highlight any pairs. This is square root, so I have a pair of 2's. That's nice. So I have 15 on the outside, and my radical simplifies into 2 square root of 3. Multiply any numbers out in front. Final answer, 30 square root of 3. Okay, so multiply coefficients. Multiply numbers underneath the radical, but don't actually figure out what the number is. Just use that as the start of your factor tree. Break those down, simplify the radical, excuse me, multiply the coefficients together. Final answer. Second way that we can do it, I can give you a radical in front of a binomial of 2 radicals. Now, I could see if these add together, but I'm not going to. I'm just going to take that out as after we do this. So I'm just remember that if I have a number in front of parentheses with pluses or minuses, I need to distribute over that multiple or over the addition or subtraction. So I'm going to do that. Now I'm going to use the fact that I have no coefficients, they're all 1, so I'm just going to do radical by radical. And again, I'm going to not actually multiply those together because I had to simplify them, so I'm just going to say this is whatever 6 times 10 is, plus whatever 6 times 12 is, doesn't matter what it is, those are the starts of my factor trees. Keep going now. This is 3 times 2, this is 2 times 5, this is 3 times 2, this is 2 times 6, and 6 is 2 times 3. All right, I'm looking for my pairs now because these are all square roots. So I have a pair of 2's. Here's a pair of 2's, and I also have a pair of 3's. So now, going back, pairs come outside. So this guy is 2 times the square root of. Numbers without partners get multiplied back together. So 2 square root of 15. Bring down that plus. This is 2 times 3, or 6 square root of. This number was alone at the end, so 6 square root of 2. These are not like radicals. I cannot put them together. So my final answer is 2 square root of 15 plus 6 square root of 2. The last type of example where you might see multiplication is just when I ask you to square something that has a radical involved. We need to remember our exponent properties. To square something means to multiply it by itself. So this is really what this question is asking us to do. I encourage you to just write it out because I don't want you to forget to square the numerator or the denominator or the radical, etc. So if I do this, I remember coefficients get multiplied by coefficients, radicals get multiplied by radicals. So 5 times 5 is 25. The square root of 3 times the square root of 3, again, using that thinking, not actually multiplying together. This is just a pair of 3's already. I'm going to not simplify it yet, though. The denominator, number times number, is 16. So this guy here is a pair of 3's, so that's going to come out. So I get 25 times 3 over 16. That's 75 over 16. If that could reduce, I would reduce it. And quite honestly, if it could reduce, I would have reduced it in this state right here before I made them bigger. But I know that 553 is the top and 44 is the bottom. There's nothing in common, so final answer is 75 over 16. So square, multiply by itself, coefficient times coefficient, radical times radical, across the top, denominator times denominator, simplify, multiply, reduce if possible. Okay? Last thing, rationalizing the denominator. You cannot ever leave a radical in the denominator of a fraction. If that happens, you need to multiply the fraction by a fraction equal to 1. So you need to multiply by a fraction that has the same numerator and denominator. And the thing that you're going to multiply is going to be whatever you need to make this go away, this radical on the bottom go away. So basically, I want to use the fact that if I get two 2's underneath, then the radical will go away. So if I multiply this by a square root of 2, did you on the top and bottom, that gives me 4 square root of 2 over the square root of 2 times 2. And I know now this is a pair of 2's, so it's going to come out. And that will happen every time. Okay, so the thing that we need to remember is we're going to end up multiplying the top and bottom by whatever square root is left in the denominator. And that's going to make the denominator be just the number that's underneath the radical to start, because that's what you have a pair of. However, I have one more step, and many of you are going to miss this. Many people often do. I now need to reduce. I can't reduce a radical with a non-radical, but I can reduce these coefficients with each other. So 4 divided by 2 is 2. The square root of 2 stays the square root of 2, and that's my final answer. So understanding numbers or interact with numbers, radicals interact with radicals, and they don't cross groups. All right, our next example. I have a fraction that's been simplified, and in my denominator, I end up with a radical. This 2 is totally fine. I do not need to rationalize it because it is a rational number already. The irrational part is the square root of 5. So that's what I need to multiply to get rid of. I want there to be a pair of 5 so I can cancel it out. So I'm going to multiply by the square root of 5 over the square root of 5. So again, that because this guy equals 1, so it's not changing the value, it's just changing the appearance. If I use my multiplying rules, my numerator is now 3 times the square root of 15, right? Coefficient times coefficient, radicand times radicand. My denominator is 2 times the square root of 5 times 5. Well, bingo, that's a pair of 5's. So I have 3 square root of 15 over 2 times 5. That's 3 square root of 15 over 10. 3 over 10 doesn't reduce. This is done. Common mistake, dropping that 2. Make sure you carry that down and multiply it by the 5 at the end. Last one, right here. A 3 and a 6 are my radicals, so I think I want to rationalize, but I realize that this guy right here could maybe be reduced. So this is the same thing as 2 times the square root of 1 over 5 times the square root of 2, right? I can reduce 3 over 6 to 1 over 2. So that means I now have 2 over 5 times the square root of 2. So it looks better, but now I still have this root 2 to deal with in my denominator. So multiplying the top and bottom by the square root of 2. So I get 2 square root of 2 over 5 times, there's that pair of 2's underneath, so it pops out as a 2. So final answer, oh, I don't want to do that. Here's why I don't want to do that. Right here, these guys, 2 over 2 is 1, they cancel out, so I'm not even going to multiply there. So I'm going to say my final answer is the square root of 2 over 5. If I didn't realize that, I would have gotten 2 root 2 over 10, and I should then notice that 2 over 10 reduces to 1 over 5. Okay, that's the end of operations on radicals.